Hello, in this video we want to look at the second section of Young and Freedman chapter 21 on electromagnetism. This is a very brief, I think we can knock this out very quickly, a couple minutes, because it's something that you likely have a lot of experience with. But let's get these basic concepts on the table. In this section we talk about conductors, insulators, and the idea of induction. So on your mark, get set, go. So what are conductors? Well, a conductor is something that conducts electricity. That's, I think, a fairly common concept. They tell you when you're a boy or a girl, don't stand near a tree in a lightning storm. Don't stand near metal things. I have a chicken coop with a metal roof, and if there's a thunderstorm coming and I'm under there, I kind of think, man, this thing is just a prime target for lightning, because metal is a conductor. And so a conductor is something in which electric charge moves fairly easily from one part of the material to another. And metals is, as I said, just the standard. If you put a lightning rod on the side of a barn or a house or something like that, the goal is, hi, strike me, hit me, kind of to attract the electricity of a lightning storm or something like that, so that we can control it, so that it goes down to the ground and bam, we're done. Rather than Mr. Ken just standing out in the middle of a field saying, oh, it looks like lightning's coming here. So a conductor is something that conducts electricity. Now, we often think of water as conducting electricity. You don't want an electric wire falling into a puddle or something like that. There's many a movie where you get rid of the villain, by they're standing in a pool of water and you put electricity in it. Don't try this at home, of course. Don't do it. Just don't do it. But actually, water, if it's pure, so the reason why water is such a good conductor is because it almost always, as we know it, has minerals in it. So the water you get out of the tap, the ordinary water, even rainwater, has other items in it, which makes it a conductor. But actually, if you have pure water, distilled water, just the H2O, ma'am, it is an insulator. So an insulator is a material in which electric charge does not move easily within the material, like rubber. Rubber is an insulator. And so I always feel encouraged when I'm in a car in a lightning storm. I'd rather be in the house, to be honest. But, if you're in a car and there's a lot of lightning, you've got rubber tires. And the rubber tires, where the rubber hits the road, is not as likely to conduct electricity. And so an insulator is something in which electric charge does not move easily. Glass, for example, plastic. These are more insulators than conductors. Again, this is fairly probably common sense stuff. You don't even know where you learned it, but it's up in your noggin somewhere. What is induction? So induction is the use of a charge in one body to create a charge in another body without it losing any of its own charge. And those kind of charges are called induced charges. So induction is a feature of motors. It's a feature of generation of electricity and things like that. It's a concept you'll get a little bit further in Young and Freedman. A little bit, I think, more complicated topic maybe when we get there. Maybe not. Maybe I'm just remembering how it was in high school. But so the use of a charge. So if you take a charged metal ball, and you bring that charged metal ball toward another metal ball, you'll create polarization within the other ball. So like if you bring a positive toward a neutral, then the negative stuff is going to be attracted to the positive ball you're bringing, whereas the negative stuff in the ball is going to go to the other end. So you're going to, even though the overall charge of the other ball might still be zero, you've got a little bit more positive on one side and a little bit more negative on the other. This can happen in molecules, for example. In a water molecule, the oxygen side of the molecule can be a little bit more negative than the hydrogen side of the molecule. It's kind of a Mickey Mouse. If you think about what water looks like, you've got these two little hydrogens, and you've got a oxygen. So the oxygen side of the water molecule will get a little bit more negative, and then the hydrogen side will get a little bit more positive. And this is called polarization. Like you've got the North Pole and the South Pole, except not really. Anyway, so that's basically it for this section on conductors, insulators, and induction.